Hello, we are the HKU Unmanned Aerial Systems team, and this is our Flight Readiness Review. So this Flight Readiness Review would include the following items: the system overview and planned tasks, which has the mechanical system, electrical system, and software system we plan to use, as well as the tasks we plan to attempt and their expected performance. Second part would be the developmental testing, which includes how we test all of the individual components for the tasks that we plan to attempt. And third is the mission testing, which includes the mission description of how we test the mission as well as the mission performance. So first, let's go over the system overview. So for the mechanical system, the unmanned aerial vehicle, we opted for a quad rotor design. For the unmanned ground vehicle, we have decided to just simplify it as simple as possible, and it will only consist of the bottle. For the dropping mechanism, we will adopt a pin release system so that it will release quickly and drop quickly and accurately. For the electrical system, for the unmanned aerial vehicle, we have adopted the Pixhawk Mini 4 as a flight controller. For the telemetry communication with the ground control station, we have adopted the SkyDroid T12 2.4 GHz telemetry system, which has a transmitter and receiver combo both at the ground control station and also at the unmanned aerial vehicle. For the flight controller, we have used a PX4 firmware instead of the conventional Ardu Pilot firmware because it is something that our team has been using for a while. For the ground control station, we have also used Q Ground Control instead of the popular Mission Planner. For the planned tasks and expected performance, we will attempt the autonomous flight task, which includes the waypoint accuracy subtask, and the expected performance is that it will hit almost all of the waypoints, and those that missed has only a maximum of 25 feet of error. So during our mission test, we have a score of 97%. We will also attempt the obstacle avoidance task. The subtask only consists of the stationary obstacle avoidance. The expected performance is that it will be able to avoid all of the obstacles. We will not attempt the object detection, classification, and localization task. This is because due to COVID, there's a lot of development that has been stopped, and due to time constraints, we are not able to develop a fully working system. However, we have the groundwork and the foundation laid out, so hopefully the team next year could be able to finish what we have started off. We will also not be attempting mapping due to COVID-related issues. We also do not have time to complete the imaging system. However, the software pipeline has been completed, so we also hope that next year's team could finish on what we have started. We will attempt the airdrop, especially the subtask of drop accuracy, and we expect it to drop within 1 meter. But we will not attempt the drive to location subtask. So as mentioned before, the UGV is only a simple bottle, so we will only do the drop accuracy and not the autonomous driving to location task. Moving on to the next part, the developmental testing. We are going to do individual component testing, in which each component is individually developed and tested before integration. The rationale behind this choice is that each component can be developed and tested in parallel. For the autonomous flight, we have conducted 7 total of autonomous flights. The average amount of time spent in manual mode per flight is negligible, as most of the flight has been conducted autonomously without the need for any manual intervention. For tuning the aircraft for autonomous takeoff, flight, and landing, we need to calibrate the sensors before every flight to ensure that the plane is in the correct orientation, no matter the location of flight. For the waypoint and obstacle avoidance performance, we have put these two in the same category as they are very similar. For the obstacle avoidance, we are simply generating a new path around the virtual object. So this is basically just going for different waypoints to avoid the obstacle. So to do the testing, we have 6 waypoints set in this test with 1 obstacle, also 1 airdrop location, and also 1 area to survey. The number of waypoints attempted were 6, and the number of waypoints hit was 4. The average waypoint miss error for those that were missed was only 25 feet. For the number of obstacles, as mentioned, we have only 1 obstacle, and we have also avoided that 1 obstacle as well. For the airdrop performance, the testing was simply dropping the bottle, but we are only dropping at a flight altitude of 5 meters, since at a higher altitude there's a lot of safety concerns since the area there was limited. So we limited the flight altitude to be only 5 meters. We have attended 2 drops, and both drops were successful. The bottle has survived 100%, and they have reached a drop accuracy of within 1 meter. For the next part of mission testing, we have a total of 6 waypoints with only 1 obstacle. The target flight altitude is also as well 5 meters for safety concerns, and the target flight speed is at maximum 3 meters per second, stating safety concerns as well. So we have also modified the time of the mission time. For the setup time and post-processing time, we have followed the rules to be 15 minutes and 10 minutes for the mission time, since the test was much smaller in range. So we have decreased the mission time from about 30 minutes down to only 6 minutes. Due to COVID-related issues, we were only able to attempt 1 complete mission demonstration, and an overview would be that we have successfully tested the autonomous flight performance, the obstacle avoidance performance, and the airdrop performance. But as mentioned, as we are not attempting the object detection, classification, and localization, as well as mapping task, therefore we are not able to successfully test these results. Regarding the coverage, we have successfully tested the autonomous flight, as there are sufficient waypoints to test the accuracy of the waypoints. For obstacle avoidance, we also believe that 1 obstacle is sufficient. As mentioned a while ago, the obstacle avoidance is basically just placing waypoints around the obstacle. So if we can get good waypoint accuracy, then we will be able to avoid the obstacles. But for the airdrop, the coverage is not enough, as the drop height was too low. But due to safety concerns, we are not able to test at higher heights. We are also not able to test the maximum flight time or the maximum flight speed of the UAV, since the area is small, and also we cannot fly too fast due to safety concerns. However, we are confident that it will be able to reach sufficient flight times and flight speeds in the actual mission demonstration. For the UAV flight time, although we are confident that it could run for the entire mission demonstration in the actual mission there in Maryland. However, we have calculated the theoretical flight time to be exactly 30 minutes, so there's not much headroom. This is due to the heavy weight. So some corrective action that we have done is that we will attempt to airdrop the UGV first, so this would reduce the weight, and therefore it will also prolong the flight time of the UAV. We estimate the score for the full mission test. For the timeline, we have changed, since we have changed from 20 minutes to 6 minutes, we have also modified the rubric. So we have total flight time for the mission is 2 minutes and 45 seconds with no post-processing time, as we are not attempting the object detection and the mapping tasks. So we would have total points of 1.0, and we have not used any timeouts, so for this part we have the total score of 100%. For the autonomous flight, we have 0.97 average points for all the waypoints, and we have no penalties, we have no manual takeovers, nor any items falling off, so we have a total point of 0.97. For the obstacle avoidance, the rubric is here as mentioned. We have 1 obstacle and we have avoided, so we have a total of 100% of the marks. As mentioned, for the object detection and mapping tasks, we will not attempt them, so we have 0 points for both of these tasks. For the airdrop, we are only attempting the airdrop accuracy, and we have managed to have it within a distance of 1 meter, which is around 3.28 feet. So according to the rubric, we have 100% of the points for the drop accuracy, but since it only accounts for 50%, so the total points will be only 50%. For operational excellence, the rubric includes operation professionalism, communication between members, reaction to system failures, and attention to safety. So an optimistic estimate would be the full marks 100%. The full mission score, as calculated, summing all of these up together with their relevant weights, we will have a total mark of 49.7%. So that is our flight readiness review. Thank you for watching. We wish all of the teams good luck.